Yes, parallel grounded lights can be dimmed. When lights are connected in parallel, each light has its own independent circuit. Dimming a parallel light circuit alters the voltage supplied to each light, resulting in a change in brightness. It is important to note that dimming may not be possible for all types of light fixtures. For example, LED lights may require specific dimmers. The dimming range and compatibility should be checked according to the specifications of the dimming device and light fixtures. The provided information suggests that the main bonding jumper is connected to multiple grounding points. This is generally a correct practice for residential electrical systems to ensure proper grounding and protection against electrical faults. However, it's important to verify that the connections are made according to applicable electrical codes and standards. In a 120/240 volt residential system, the grounding system plays a critical role in electrical safety. The main bonding jumper connects the neutral conductor to the grounding electrode system at the service entrance. This connection ensures that in the event of a fault, the fault current has a low impedance path back to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to quickly trip and clear the fault. Grounding electrode systems typically involve multiple components, including ground rods, metal water pipes, and concrete-encased electrodes, often referred to as UFA grounds. Connecting the main bonding jumper to the water main, two ground rods, the meter socket, and the neutral bar in the panel creates a comprehensive grounding network. This network provides multiple paths for fault current to flow, enhancing the effectiveness of the grounding system. The National Electrical Code, or NEC, provides specific requirements for grounding electrode systems. Section 250.52 details acceptable grounding electrodes. A metal underground water pipe is often used as a grounding electrode, but it must be supplemented by an additional electrode, such as a ground rod or ground ring, as outlined in 250.53 subsection D. Ground rods must meet specific requirements for length and diameter, and they must be installed at least 8 feet in length according to NEC 250.53 subsection G. The NEC also addresses the connection of the grounding electrode conductor to the grounding electrodes. These connections must be made in a manner that ensures a permanent and reliable connection. Bonding is another essential aspect of the grounding system. Bonding involves connecting all metal parts that are likely to become energized, such as metal conduits, metal enclosures, and metal water pipes, to the grounding system. This equipotential bonding reduces the potential difference between these metal parts, minimizing the risk of electric shock. The main bonding jumper plays a central role in this bonding process by connecting the neutral conductor to the equipment grounding conductors at the service entrance. In a residential setting, the grounding system should be carefully designed and installed to comply with the NEC and local electrical codes. It's important to ensure that all connections are tight and corrosion resistant and that the grounding electrodes are properly installed. Regular inspection and maintenance of the grounding system can help identify and address any potential problems before they lead to safety hazards. When dimming lights in a parallel circuit, it's crucial to consider the type of lighting being used. Incandescent lights are generally easy to dim using standard dimmers, as the dimming action simply reduces the voltage supplied to the bulb, which in turn reduces the light output. However, LED lights and compact fluorescent lights, or CFLs, require specific dimmers that are designed to work with their electronic circuitry. Using the wrong type of dimmer with an LED or CFL can result in flickering, buzzing, or premature failure of the bulb. When selecting a dimmer for LED or CFL lights, it's important to check the compatibility of the dimmer with the specific light fixture. Many LED and CFL manufacturers provide a list of compatible dimmers on their websites or product packaging. It's also important to consider the dimming range of the dimmer. Some dimmers have a limited dimming range, which means that they may not be able to dim the lights down to a very low level. This can be a problem if you want to create a very dim or ambient lighting effect. In addition to compatibility and dimming range, it's also important to consider the power rating of the dimmer. The dimmer must be able to handle the total wattage of all the lights that are connected to it. Overloading a dimmer can cause it to overheat and fail. When working with electrical systems, it's always important to follow safe work practices. Turn off the power to the circuit before working on any wiring. Use insulated tools to prevent electric shock. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Proper grounding is essential for electrical safety. It provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. The main bonding jumper is a critical component of the grounding system as it connects the neutral conductor to the grounding electrode system. The grounding electrode system typically consists of multiple grounding electrodes such as ground rods, metal water pipes, and concrete encased electrodes. Bonding is another important aspect of the grounding system. It involves connecting all metal parts that are likely to become energized to the grounding system. This reduces the potential difference between these metal parts, minimizing the risk of electric shock. When dimming lights, it's important to consider the type of lighting being used and to select a compatible dimmer. LED lights and CFL require specific dimmers that are designed to work with the electronic circuitry. Always follow safe work practices when working with electrical systems. Turn off the power to the circuit before working on any wiring. Use insulated tools to prevent electric shock. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The connection of the main bonding jumper to the water main, 2 ground rods, meter socket, and neutral bar in the panel ensures a robust and effective grounding system. This configuration provides multiple paths for fault current, enhancing safety and minimizing the risk of electrical shock. Understanding the principles of grounding and bonding, as well as the specific requirements of the NEC, is essential for ensuring the safety and reliability of residential electrical systems. When dealing with electrical systems, especially in a residential setting, it's important to be aware of the relevant codes and regulations. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It provides detailed requirements for grounding, bonding, wiring methods, and other aspects of electrical systems. Compliance with the NEC is essential for ensuring the safety of people and property. In addition to the NEC, local electrical codes may also apply. These codes may have additional requirements or modifications to the NEC that are specific to the local area. It's important to check with the local authorities to determine which codes apply to your electrical installation. When planning an electrical project, it's a good idea to consult with a qualified electrician. An electrician can help you design a safe and compliant electrical system and can perform the installation work. Working with electricity can be dangerous, so it's important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on any wiring. Use insulated tools to prevent electric shock. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The presence of multiple grounding electrodes, such as the water main and ground rods, enhances the overall effectiveness of the grounding system. Each electrode provides a path for fault current to flow back to the source, and the combination of multiple electrodes creates a more robust and reliable grounding network. The connection to the meter socket also contributes to the grounding system by providing a path for fault current from the service equipment. The neutral bar in the panel serves as a central connection point for the neutral conductors in the electrical system. The main bonding jumper connects the neutral bar to the grounding system, ensuring that the neutral conductor is properly grounded. It is also good to remember that the NEC 250.24 deals with grounding requirements for separately derived systems. A separately derived system is an electrical power source, such as a generator or transformer, that is not directly connected to the utility electrical system. When installing a separately derived system, it's important to follow the NEC requirements for grounding to ensure that the system is properly grounded and protected against electrical faults. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the ungrounded conductors at the service. The grounding electrode conductor must be large enough to safely carry the maximum fault current that could flow through it. Improperly sized grounding electrode conductors can overheat and fail, compromising the effectiveness of the grounding system. The grounding electrode conductor should be unspliced or spliced only by reversible compression type connectors listed for the purpose. The connection of the grounding electrode conductor to the grounding electrode must be made by approved means, such as listed connectors or exothermic welding. The point of connection of the grounding electrode conductor to the grounding electrode must be accessible. The neutral conductor is grounded at the service entrance to provide a reference point for the electrical system. This grounding helps to stabilize the voltage and prevent voltage fluctuations. The grounded neutral conductor also serves as a path for fault current to flow back to the source. This helps to ensure that overcurrent protection devices, such as circuit breakers and fuses, will trip and clear the fault quickly. In addition to the main bonding jumper, there are other bonding jumpers that are used in electrical systems. Equipment bonding jumpers are used to connect metal equipment enclosures to the grounding system. These jumpers ensure that all metal parts of the equipment are at the same potential, reducing the risk of electric shock. Piping system bonding jumpers are used to connect metal water pipes and gas pipes to the grounding system. These jumpers help to prevent the buildup of static electricity in the pipes, which could cause a spark and ignite flammable materials. Understanding the principles of grounding and bonding is essential for ensuring the safety and reliability of electrical systems. By following the NEC and local electrical codes, and by using proper grounding and bonding techniques, you can help to protect people and property from electrical hazards. The grounding system should be inspected periodically to ensure that it is in good condition. Check the connections to the grounding electrodes to make sure that they are tight and corrosion-free. Also, check the grounding electrode conductors to make sure that they are not damaged or corroded. If you find any problems with the grounding system, have them repaired by a qualified electrician. The grounding system is an important part of the overall electrical system. By understanding how it works and by maintaining it properly, you can help to ensure the safety of your home and family.